By the end of this video, you'll have a basic understanding of everything that you need to know to convert the sun's energy through your solar panels into power that you can use in your everyday life, whether that's on-grid or off-grid. The first and probably most important part of any system is the solar panels themselves. These come in a huge variety of sizes, powers, and efficiencies. Like this panel right here, for example, produces up to 395 watts, but this one that's almost the same size produces only 250 watts at best. And no, that's not because it's shattered. It actually works quite well despite being shattered. It just doesn't have the same capacity as the newer, nicer ones. Now, the more power they produce per area, the more they tend to cost, which could be a factor if you have limited space on your roof or wherever it is that you're placing the panels. There are also portable panels like these, but they tend to produce a lot less power. They are, however, great for portability and for lower power needs like charging a phone. I'd say the two main things to consider when looking at solar panels are the wattage output and also just making sure you've got the right voltage. And nowadays you can also buy what are called bifacial panels like this one, that even if the back is at all uncovered, they absorb light from the back, adding up to as much as 30% power output. I set this one up so that it's not actually getting any direct sunlight, but it's still collecting power from both the front and the back and producing about 39 watts of power. Not too shabby. The second ingredient is inverters. Now, inverters can either be up with the panels, and these are called microinverters, or they can be downstream where all of the panel's wires are collected in what's called a string inverter, and you can even use both. Their job is simply to convert the DC power that comes from the panels to AC power that we can use for our devices and appliances. Microinverters typically connect to between 2 and 4 photovoltaic panels, or these solar panels, and they make it really easy to expand or condense, if you need to, your system. You can add monitoring systems to these, but they do have to be serviced up on the roof and typically underneath the solar panels, so they can be challenging to get to. Now, because microinverters handle power in smaller groups, if certain panels are shaded or underproducing, it typically has less of an impact on the total power production. String inverters bring all of the panel wiring into a central location, and they have a specific size rating in order to accommodate up to a certain number of panels based on wattage and voltage. Now, if you have to set your panels up in series to accommodate your string inverter, your panels will only be as productive as your least productive panel, though power optimizers can help with that. It's also possible to use a combination of microinverters and string inverters if that makes sense for your setup. Now, it's worth noting that certain string inverters actually require a battery to work since they're designed for off-grid situations. So be sure to check out those details before you buy. Another major consideration when choosing between microinverters and string inverters is whether or not you want the ability to reroute power to your house during a power outage. To do that, you need to disconnect it from the grid like we can do with this setup. This can allow us to keep our freezers running and a couple of lights on, for example, in case of a blackout. Now, not all inverters allow for that, especially when you're looking at microinverters. Now let's pause for a second to explain series versus parallel, because that's something you definitely need to understand when connecting batteries and panels. So series, when you connect something in series, that means the positive of one panel or battery is connected to the negative of the next. This puts them all in line with each other. And you can think of it like a TV series. There are certain TV series where if you skip them or go out of order, you're going to get totally lost. So you actually need to watch them in order. Episode 1, Episode 2, 3, and so on. This is also how the old Christmas lights were set up, which was super annoying. One bulb would go out, you're not sure which one it is, and none of them worked, and it's just horrible. So with parallel, on the other hand, you're connecting every positive line together and every negative line together. So you can pull one out of the mix and it really won't matter. It won't affect the rest of them. The other big thing to know about series versus parallel is how the power gets added up. So the difference between series and parallel is one will add up the volts of each and the other one will add up the amps of each. Now, in trying to come up with a good way to memorize this, I decided to use the word suave. And if you think about the letters and break them down, you can say in series, you add volts of each. So in this case, with the series, the amps stay the same. If you put, for example, two 250 volt 10 amp panels together in series, they'll produce an output of 500 volts and still that same 10 amps. Now the opposite is true for parallel. These same two panels will produce the original 250 volts, but also 20 amps of power. This is really important in how you connect batteries. This inverter, for example, can handle 24 volts. So I've connected these two 12-volt batteries in series. That means it's adding up their voltage to produce 24 volts. And then the amp hours stay the same, which in this case is 150 amp hours. This other inverter, on the other hand, is a 12-volt inverter, so I connected these two 12-volt batteries in parallel. That means they still add up to only 12 volts, but they give me double the amp hours, so 300 amp hours. It's also very common to mix and match series and parallel to meet your needs, but no matter what type of circuit you go with, you do need to understand the output that you'll get as a result. Now, I totally understand that some of this can get pretty overwhelming, which is why I'm trying to keep it a little bit high level here, and I'm not going too far into some of the details. But if you're just overwhelmed by the idea of understanding all that goes into solar, and especially doing it yourself, there are some great options out there for you. Now, this video is in no way sponsored, but I do want to tell you that there are options out there that can save you a lot of money and still be a high quality installation. As I've done my research and looking at my system that's almost 7 years old, I wish I had the options that are out there today. And when I look around, one of the best options I see is actually going with Tesla, which does very similar systems to what I've got here, but they do it for a lot lower price than what I paid. So I've got a coupon in the description that you can use to save $300 off any installation. It's just a referral code. It helps me out and it saves you a few bucks too. So if you're interested in doing something that's not DIY, that's a great option that you can check out. They actually have a configurator right on their site that you can put everything in, see what the cost will be for you, see what the loan options are versus paying it out of pocket, all that good stuff. So feel free to check that out if that's something that you're interested in. Having said that, let's explain the rest of the system so you can see how this all comes together. Now, just as a reminder, all electrical work that you do of this nature should definitely be checked by a certified electrician, and then you need to make sure to adhere to all local guidelines, local codes, and whatever it is that your town tells you to do with solar in your area. All right, on to our third ingredient, which is switches and safety measures. Now, there are several different versions of these. So here I've got a PV combiner, which is just a really nice box with fuses and switches to be able to allow you to connect multiple solar panels to one output. You can also use circuit breakers. There are disconnects involved, both DC and AC. There are fuses, and each of these basically serves two purposes. The first, and the one they all do, is they create a break point between one portion of your system and the next. They make it easy to disable power to a section so that you can service it. Now, the second one that almost all of these do is they also provide protection from surges and overloads. And electrical code requires these in certain locations, but it's always best to err on the side of having too many in place for safety's sake. The only one of these that does not provide any overload protection is the disconnect boxes. Those really are just an on-off switch that you can use. Now, when it comes to deciding how much power you need to generate with your solar system, consider this analogy. Imagine you have no running water at your home, but you do have a water tank out back. You also have a large opening on the top of the tank to collect that water, but it only rains for about 4 hours per day. Now, you've got a water pump that pushes the water from your tank to your house so that you can actually use it. Now, in this analogy, the tank is your battery system. The opening to the tank is your solar panel array, and the pump is your inverter. If you're not getting enough rain into your tank, you need a bigger opening to collect the rain, which means more solar panels. If you're not getting enough water from the tank to your home, you need a bigger or better pump, which is, in this case, a better inverter. And if you're using more water than is in your tank, you need a bigger tank, which is a bigger battery system. On that note, let's talk about batteries, which is the fourth ingredient in our recipe. Well, there's a ton to cover with batteries, so we won't get into all of it, but there are several kinds of batteries out there that can be used to store power from a solar panel system for later use. If you're building a grid-tied system, you don't actually need to use batteries unless you want to add protection against power outages. You can use a Tesla Powerwall for this, or you can use your own batteries. If you are building an off-grid system, however, batteries are essential for power storage. Just like with solar panels, these can be combined for additional storage. In addition to solutions like the batteries that we've shown here, as well as the Tesla Powerwall, there are even certain electric vehicles coming out that claim to be able to power your house. Like the Ford F-150 Lightning says it can power your house off the Ford's battery to provide power for up to as much as a few days, which would be pretty awesome. So I'm sure we'll see a lot more of that sort of thing coming out over the next several years. Batteries do have a voltage rating, like 6 volt, 12 volt, or 24 volt typically. They also have different amp hours, kilowatt hours, cycle count efficiencies, temperature ratings, and more to compare. So we won't get into all of that for now, but I will say that you do need batteries to store power if you're not tied to the grid, and they're optional if you are. Now, the last ingredient is the wiring and connectors to connect all the pieces together. There is, again, a lot to get into here, but if you're using wires that are going to be outside at all, they need to be outdoor rated. or you need to use what's called THHN or THWN wire that goes inside of electrical conduit. THHN wires are individually sheathed cables that are rated for exterior use inside a conduit. A cheap alternative to using the solar-specific panel wiring is just to use some 12-gauge landscape wiring. This actually works really well. You just need to connect your MC4 connections, which is what most solar panels use as their connector. MC4 connectors are great because they make it really easy to see that you've got a secure connection, they're weatherproof, and you can both feel and hear when they make that perfect connection. Now for wiring up batteries, you usually need a much heavier gauge wire because there's more amperage going through. So I'll often use this 2-gauge wire, which also requires the use of either a 3/8 or a 5/16 copper lug, and then some pretty heavy-duty crimpers to put these together. So those are those 5 ingredients. Now to put those together, we're going to connect the solar panels to a fuse or a PV combiner box. That gets connected to an inverter, and then you can connect your inverter to either batteries or the grid. For the off-grid setup, this is pretty much the whole install right here. You can connect outlets to this if you need to, but more typically you'd connect this to a circuit breaker panel that is completely non-grid tied. For grid tied, you would run wiring from your inverter through an AC disconnect box and then into your main circuit breaker panel like this. This provides power to the rest of the circuit breaker panel, and your power company will install a bidirectional meter that measures how much power is coming in from solar versus how much is being used at your residence. With that, you've got working power to run your appliances and devices directly from the sun's rays. How awesome is that? I'm Nils with Learn to DIY. Thanks for watching.